Yes, we know that air is the cheapest source of oxygen that we have around that can lead to the combustion reaction. So we have to first know what are the gas components that make up air, right? So air, as we know, air consists of nitrogen and oxygen, and the content for both is 79% of nitrogen and 21% of oxygen in air. So you might have traces of other gases as well, for example, carbon dioxide, helium, neon, krypton, and etc. in air, but they are in very small traces. So what we have here is that these gases were reported in dry basis, right? These gases are reported in dry basis. So the ratio of nitrogen to oxygen in air is about 3.76 mole of nitrogen to oxygen. Okay, so the traces or the mole ratio of nitrogen to oxygen is about 3.76, and this is also very important for you to memorize, because it will make your calculation much easier. So let's go back to our wet basis here. What does a wet basis mean? Wet basis means that the mole fractions that are reported include the mole fraction of water, right? As shown in this example here, you have 30% CO, 50% N2, 20% H2O. So this is reported as a wet basis because it includes the mole fraction of water. If we exclude the mole fraction of water, then the calculation will be slightly changed. As you can see, the next sample there, we have 37.5 mole of CO and 62.5% of N2. Okay, 37.5% of CO and 62.5% of N2, and this one here we call, or we report it as a dry basis. So dry basis is also known as Orsat analysis. Okay, Orsat analysis and dry basis, they are the same. Okay, it is how we reporting the mole fractions of the gases. Means that in Orsat analysis there is no H2O reported with the gas stream. It might be reported individually, right? Whereas the flue gas or the stack gas that comes from our combustion furnace. Okay, we have our combustion furnace. So the combustion furnace that has these gases usually reported with H2O composition included in the calculations of the gas mole fraction. Okay, and the next one that we have is a dry flue gas, which is SO2 free basis. So here we are removing both the SO2 and H2O content. Okay, so we don't have any SO2 and H2O content in the calculations or in the reporting of the gas compositions that live in the stack. But this will be reported individually because we have to make sure that the mass are conserved. Okay, let us see now. We have a propane that is combusted using air, and it actually lives in stream 3 as product where we have a flue gas, right? We have a flue gas or stack gases that live in the combustion furnace, and we have it reported as a dry basis. And then we have water that is reported separately from the gas component, right? So for a flue gas, here we can report them both in either a wet basis. So when you want to report them in a wet basis, then we are going to add in water. But if you are reporting them in a dry basis, you are going to remove water. Okay, let's look into this example here, how we are converting from a wet basis given data to a dry basis values. Using a basis of 100 mole of gas that is leaving through stream 3 here, all right? So we have gas A, gas B, and gas C, and their makeup is coming up to 94.0 mole%. As described in the process description, the remainder will be water. So water will be 6.0 mole%. If we are reporting the amount of this gas fraction here in a dry basis, then we are taking the denominator by removing the water content and only put the total dry gas content as the denominator. Then we are altering the mole fraction a little bit. Gas A is now about 17%, gas B is 78%, and gas C is 5%. So there is a slight changes when we reporting from a wet basis to a dry basis, and we can see here that we are not reporting any water content, right? So no H2O is reported, because we already omit the value of H2O in our initial calculation when we take the denominator as 94 mole only. Okay, let us now look how we can convert from a dry basis, okay, from a dry basis data to a wet basis data. If, let's say, we still have a 100 pound mole of dry gas, all right? Our basis is 100 pound mole of dry gas. So our gas component add up making the 100% of dry gas, which is about 100 pound mole. But when we send the sample of the gas in a gas analyzer, we detected that there is a presence of about 0.03 pound mole of water for every 1 pound mole of wet gas, right? So when we do the analysis using gas analyzer, this is what we have. It means that what we presented here are only a dry basis, but if we want a wet basis information, then we have to take into account the water that had been detected by our gas analyzer. So how do we go about converting from the dry basis to the wet basis? So we have our information just now, which is 0.0300 pound mole of water per pound mole of wet gas, right? That is the information that we have. We also have the information that if we have that amount of water, then if we are making it a 100% on wet basis, then for a 1 mole of wet gas, we will have 0.97 pound mole of dry gas only. Okay, doing some mathematics, then it will come back to 0.0300 pound mole of water per 1 pound mole of wet gas. So we want to get what is the amount of water per amount of dry gas. Then we know that for every 1 pound mole of wet gas, we have 0.9700 pound mole of dry gas. Okay, so that is the information that we have So we can cancel this and we will have 0.0309 pound mole of water per 1 pound mole of dry gas. Multiplying that with 100 pound mole of dry gas, then we will have our total amount of water in that gas sample is about 3 pound mole of water. So from converting from a dry basis to wet basis, we need some sort of like a sample analysis or a gas sample that will tell us what is the actual or what are the fractions of water with respect to the wet gas sample that we have.